the last section of the chapter, which is called Application to Mechanics. Okay, and obviously there's a link between this and the mechanics that you learn in applied. Okay, so the question is on page 347, and this is the first example. So basically the knowledge that you need is all the equations of motions that you've learned in your first year of applied in the mechanics section, and any knowledge that you've gained in your second year mechanics section as well. Okay, so in this example we've got a particle of mass which is 0.5 kg, and it's being acted on by three forces, and we've got F1, which is 2I minus j plus 2k newtons. Okay, F2, which is minus I plus 3j minus 3k newtons. And the reason why we've got force as a vector, force can be written as a vector, is because force itself is a vector quantity. So it's got direction and magnitude. Okay, so we've got these three forces, and the first part says find the resultant force R. So resultant force R is just the sum of all the forces that are being acted. So it's F1 plus F2 plus F3, and again I'm going to work in column vectors because it's just much quicker. And if I added them up, I will get 5 minus 1 and minus 3, and I want to be able to write this in the IJK form. Okay, next part B says find the acceleration of the particle, giving your answer in the form pi plus qj plus rk meter per second squared. So for this you need to know this equation, F equals ma, okay, mass times acceleration. So we've got the force, which is 5I minus j minus 3k, equals, we know the mass, times acceleration. So the acceleration is then 10I minus 2j minus 6k. Okay, half is 1 over 2, multiply 2 by each of these quantities, and that's what you're going to get. And don't forget to include the units. We've got meter per second squared. Okay, part C says find the magnitude of the acceleration. So you know how to find the magnitude of a 3D vector. That was the first thing that you learned in this chapter. Okay, and if you did this, if you entered this in your calculator, you're going to get root 140. Just make sure you've read the question carefully, whether to give your answer in exact form or to a few decimal places. Okay, I'm just going to leave it like that. Now part D, for part D, again you're going to have to know your equations of motion, which you've learned in your applied section of maths. It says that the particle starts at rest. So if it starts at rest, that means u must be equal to 0. Find the distance traveled by the particle in the first 6 seconds of its motion. So t is equal to 6, and we need to find the distance. We know the acceleration. Okay, so to calculate any unknown quantity from your Newton's laws, from your Newton's equations, you need to know 3 quantities. Okay, there need to be 3 known quantities, so you can work out the missing quantity. And the equation that I think we're going to use is S equals ut plus half at squared. And if you use this equation, because you know u, you know t, you know a, and you know t again, you'll be able to find S. Okay, and if I was to input all values, S equals ut is going to just become 0 because u is 0, so half times root 140 times 6 squared, and that will give me 36 times by 35, root 35 meters. And whatever the question says, give your answer to significant figures or one decimal place, you give your answer accordingly. Okay, but because they didn't give me any guidance, I can just leave my answer in this exact form. Okay.